speed and velocity, these are called rates. At least if you're talking about mathematics, these are called rates, or rates of change. All right, speed measures your change in distance traveled as time passes. All right, so if you start a timer here and then you start walking and you go and then you stop, however much time that took, and however much distance this was, that would allow you to find this rate. Specifically, it's your speed, and so it's the amount of distance divided by the amount of time. That's how to get this rate of change. It's the rate of change of distance over time. So the important part of speed is that it uses the concept of distance in order to calculate it, or to find it, or to think about it. You think of speed in relation to how far you've traveled, how far you've moved. On the other hand, velocity measures your, instead of yours, say the amount of displacement. Remember, displacement is change in position. That occurs as time passes, or in a given time period. We'll say in a particular time period. And the big distinction here is, of course, velocity uses the concept of displacement, the rate of change of the displacement, versus speed, the rate of changes of distance. So this means you got point A, point B here. This may be where you went. All right, that's your journey, but your displacement is going to be this distance. All right, and of course the time is the total amount of time it took for that displacement to happen. And why do I have a D there? That's not the D. That is called R delta X. This straight line distance from one point to another is our delta X. So then our velocity becomes delta X over delta T. Okay, so if you get the distance between distance and displacement, speed and velocity, it's not that big of a step to get those. The big thing to get is that distance and displacement are unique, and how they are unique. Even though they're both measured in meters, they can mean very different things. So let's move on to examples. So our first example, we have a track. All right, we're doing a race. All right, we've got 4 competitors. 1, 2, 3, and 4. All right, the starting line is right here. Start. And the finish line is right here also, finish. All right, so competition, first person around the track wins. Actually, let's make it more interesting than this. So we're gonna have two competitions here, not just one but two. Competition one, person with the greatest average velocity wins. Competition 2, person with the greatest average speed wins. All right, so in this race we have two different conditions to win, and so yeah, we'll have two different winners. So let's see, the purple X, that's not purple. All right, the purple X goes around the track, finishes, let's say this track is, we'll just call this track 1 kilometer long. 1 kilometer, not long, but 1 kilometer circumference. All right, so each runner is going to end up going 1 kilometer if they go one way around. So the purple X, the purple person, they finish the race in 5 minutes. Okay, the red person, so 5 minutes, 1 kilometer. The red person, let's say that red person takes 6 minutes to do 1 kilometer. The yellow person doesn't finish, so the time is ongoing and ongoing, infinite number of minutes. And since they got hurt and taken off the stretch, or let's say they went, you know, we won't say infinite minutes. That's too much. We'll just say they didn't make their kilometer. They got to 0.5 kilometers, and let's say they got carried off the stretcher after like 8 minutes. All right, so they fell down. They were laying down for a bit, and then they got carried off at the 8-minute mark, and so their race was done. And the last person, this person didn't move. 0 meters, 0 seconds. The last person just stood there. So the question is, with these 4 people, who's got the greatest average velocity? Who's got the greatest speed? We're going to do competition 2. We're going to judge competition 2 first because it's a little more what you expected. So speed uses distance over time. So, you know, the people with the... So if we compare the 3, we got 1 kilometer divided by 5 minutes. Let's do purple. 1 kilometer divided by 5 minutes. So that is 0.2 kilometers per minute. So that's their average speed. The next one, 1 kilometer in 6 minutes. So that is 0.167 kilometers per minute. The third one, 8 minutes and a half a kilometer. So that would be 0.5 km divided by 8 minutes. And what is that? So about 1/16. So 0.06 25 kilometers per minute. And the last one, what do we do here? 0 meters over 0 seconds. 0 divided by 0 is undefined. We don't know what's going on with that. They're either going infinitely fast or infinitely slow. So what do we do with that? That's just insane. Makes my head explode. So, but luckily, we can think about this a little bit. And if we think about this, they're not moving at all. They haven't moved at all. So, so instead of saying 0 meters in 0 seconds, why don't we, this race didn't take 0 seconds. This race just took a certain amount of time. So we'll say the race is over when the last person gets taken off. So we'll use, actually better than that, we will give this race a time limit. So the time limit is 10 minutes. If you haven't finished in 10 minutes, you're done. So we got 0 meters in 10 minutes. All right, so their velocity is, what is their velocity? 0 kilometers per minute. All right, so who has the greatest speed? Well, this is pretty straightforward. If we look at all of them, well, 0.2 kilometers per minute, greatest speed, purple wins. So competition 2, winner, purple. Well, who won okay, so that may have been what you expected. Excuse me. But let's see what happens with competition 1. So we got to find a place to put competition 1. So I think we'll have to do a new page. So comp 1, greatest velocity. And we're not going to do calculations on this one, and you will see why shortly. We're just going to we're going to think conceptually about this. Alright, so that's a horrible, this is a horrible track period. I'm sorry. Alright, so we've got our purple, we'll say green, I forgot what the color of the X's are, orange, and this other purple. 2 different types of purples, maybe violet and purple. Alright, so we got our 4. Greatest velocity, who's got it? Well, the first purple, remember, 8 minutes, so purple, 8 minutes, 1 km. Green, actually it wasn't green, it was red, now I remember. So let's give this one red. Red was, actually it wasn't 8 minutes 1 kilometer, this one was 5 minutes 1 kilometer. And this one was 6 minutes 1 kilometer. This one was, and these are distances. The 1 kilometers are distances. That's around the track one time. Orange, 0.5 kilometers, 8 minutes. And the last one is this violet, 10 minutes, 0 kilometers. So what do we see here? Well, I'll sort of do calculations. Velocity is displacement over time. So this person goes 1 kilometer, but look again at this. The starting point is right here. 1 kilometer later, they go. They end up right here. So the ending point is also right here. So x initial, x final. So we have delta x is 0 minus 0 over 5 minutes. Well, look at what we have for red too. We have for red we have 0 minus 0 this time over 6 minutes. But you know, 0 over 5 is still 0 meters per second. Even though this one took longer, 0 out of 6 is still 0 meters per second. So far with velocity, none of them have done anything. Purple and red, nothing. We'll skip orange for now, and we'll go straight to violet. Violet went 0 kilometers in 0 minutes, also because violet stayed at the starting line. So violet, even though violet did not move at all, and the purple went the fastest around, the red was the second fastest, the violet has an equally fast velocity. And now we go to the injured person who didn't even finish. What is their displacement? Well, that's a little complicated because they got hurt halfway through, so we'll say it's right there. So this isn't 0.5 kilometers away this way, not 0.5 kilometers, but the person didn't finish, so they didn't end at your starting point. So this is not 0 kilometers either. All right, so this has a positive displacement. So positive displacement. I don't know what it is exactly. It depends on the shape and all this. But maybe we'll say, you know, it could be like a quarter of a kilometer. But regardless, I'm not even going to put numbers to it. But we will say that we'll just leave it at this. The velocity of orange is greater than 0. We don't know exactly what the velocity is, but we know orange won because they didn't start where they ended up. Orange won because they had a real velocity. Their ending point right here was not the same as their starting point. Everybody else's starting and ending point was the same. So the injury was the entire reason that orange wins the competition. So competition 1, orange is the victor. Okay, so this is how distance and displacement are so different. You know, it just seems like calling the orange the victor kind of misses the entire point of the race. And I mean, really it does. So this is why it matters whether you're talking about speed and distance or displacement and velocity. All right, so if you're using the language of displacement and velocity, talking about a race would not be the appropriate kind of venue or context or, you know, situation to be using that language. The more appropriate language would be speed and distance. Okay, so now we need to do some speed and velocity practice. So to do practice, we are going to we're going to try and mimic the distance and displacement type ones. So here we have situation one. We'll go from place X to place Y. And this is how we get here. Alright, and this is how far apart they are. Let's say they're 10 meters. Alright, and let's make them in big blue dots. Alright, and now we need the journey here. Let's say we go, I don't know, 0.5, 1.25, 2, and all of these are meters. Let's go 1 meter, 0.25 meters, 3 meters, 2 meters, 2 meters. All right, and regardless, and this whole journey, remember, pink is journey. Purple is how far away X and Y are. All right, so we'll say the time it took to do that was like 30 seconds. T is 30 seconds. So for this, your two questions are V equals, and we'll say the average velocity, and we will also say, we'll make them color-coded, sorry. V average equals, and V sub S speed equals what? So find the velocity, find the speed. In order to find the velocity, you need the displacement first. In order to find the speed, you need the distance first. So that's problem one. Let's make some that are also a little bit simpler. So we're still going to do X and Y in each case. All right, this one will be, this one won't be have as many twists and turns. So we got our purple. We'll say that's 2 kilometers away. All right, and then we'll say, in this case, the journey is like this. And the pink says 2 kilometers as well. Alright, so we've got purple down here, 2 kilometers. And we've got pink there, 2 kilometers. And so we need the V, and we need the V sub S. And let's do a number 3. We've got X, Y, purple again. We'll call that 20 meters. And then we've got our journey that went like this. So we'll call this 15 meters and 15 meters. So V average equals question mark, and V sub S equals question mark. And 2 more. 4. All right, we'll go X, and we'll go Y. All right, so displacement is here to here. We'll say that's 1 centimeter. And then we'll say our journey is all the way across. So if that's 1 centimeter, then this is like maybe 10 meters, 0.5 meters, no, 1 meter. Okay, 20 meters, 1 meter, 18 meters, 2 meters, 5 meters, 2.5 meters, 1 meter, 7 meters, 3 meters, and 5 meters. You know what I've been forgetting? Time. The time here will be 15 seconds. The time here will be 2 hours. And the time here will be, this is so squishy. We can't use this color. Let's use a different color. Time here is, let's give it 15 minutes. And last one, number 5. X is the starting point and the ending point. So in the purple, well, I guess there is no purple because X is the starting and ending point. But for the pink, whoop. Okay, and we'll make this a kilometer, and we'll say the journey took, I don't know, 20 minutes. So for each of these, what is the speed? Alright, and what is the velocity? And for this one, what is the speed? And what is the velocity? Alright, those are your problems. This will help you for the test. Hope you're good. Alright.